Hi, this is Mrs. McGrath. So we are going to talk about relations and functions. We're going to learn how to write functions in their specific notation, and we're also going to be able to determine the difference between a function and a relation graphically. A relation is a set of ordered pairs. As you can see in this particular example, there are 4 ordered pairs, 1, 5, 3, -7, 4, 8, and 4, 10. There's no restrictions. As long as every x has a y value that's linked with it. However, a function is also a set of ordered pairs, so a function is a relation. However, there is the restriction that every input has only one output. So you can see up in the relation up here, this is not a function because this x value of 4 has both a y value of 8, but 4 is also linked with a y value of 10. So this x value of 4 has 2 y values, or 2 outputs, so it is not a relation. Whereas down here, x, which is 1, is linked with the output 5, 3 is linked with -7, 4 is 8. There's no duplicate values. We've been studying equations of lines. If you were to think about y equals x plus 7 visually, here's a line, and if you notice, for every x, we have a unique y value, which is really just a collection of points along that line. Another way to write y equals x plus 7 in function notation is to take your y value and replace it with f of x. I can rewrite x plus 7. And you and I know that if we were to input a value of 1 for x, we would end up with a y value of 8. And really what this is saying is the function value at 1, if you let x equal 1, you end up with 1 plus 7, or 8. So it's just another way to write the equation of a line, just in function notation. So same thing here, y equals 2x minus 3. I can rewrite this in function notation of f of x is equal to 2x minus 3. If I were to give this to you in tabular format, I've got 3 points here. I could say come up with a function rule, or basically what we're really doing is we're just trying to come up with the equation of a line. First thing we could do is we could try to say, okay, well, is it a line, or are we going to find the slope? So I notice that this is going down 2, and this is also going down 2. I notice that this is going down 7, and this is going down 7, so therefore I can see that my slope is positive 1, because I've got -2 divided by -2. Once I'm here, I can say, all right, well, I've got a slope of 1. Let's solve for our b value. We can plug in whichever point we want. I'm going to choose the point 3, 0. When x is 3, I have a y value of 0. So if I subtract 3 on either side, I end up with b is equal to -3. So before, we had the equation of the line y equals 1 times x minus 3. As a function, however, function notation, we're going to write it as f of x equals x minus 3. Some of you could kind of guess this. In middle school, you talked about inputs and outputs. If you have an input of 12, how do you get to an output of 9? Well, you're just subtracting 3. So if I were to put an input of 12 in, just to check my answer, I would write 12 minus 3, and I have an output of 9. So I have the point 12, 9. An input of 10, if I were to put 10 in, I would say 10 minus 3 is 7. We have an input of 3 and output of 0. In this example, I'm going to give you 3 different functions. You're used to function notation, f of x. You can also have g of x or h of x. It really just means that this is a function of x. So you could see f of x, g of x, h of x, pretty much any letter, I of x, you name it. So in example 1, I'm asking you for f of 3. So I'm going to write it right underneath for right now, but as you can see, wherever I see an x, I'm actually going to put in 3. So here's my x in the f of x function. It's 3 plus 7, so f of 3 is equal to 10. If I want g of 5, I'm putting 5 wherever I see an x, so it is 2, there's that x right there, times 5 minus 1. That's equivalent to 10 minus 1, so we actually get 9. If we have h of 6, I'm going to come over here at the right. H of 6, wherever I see an x, I'm going to put a 6. And this rule is actually a little bit more complicated. It's not a line like the previous two. It's a function, x squared minus 3. But I do the exact same thing. Wherever I see the x, I put the 6. I'm squaring it in this case, and then I'm subtracting 3. So I'm going to get 36 minus 3, or 33. Here's one more example of write the function. Some of you are quite good at noticing a pattern, how you can get from an input of 1 to an output of 3, an input of 2 to an output of 5. If I were to input 3, how do I get to 7? For those of us who can't see it, we're going to try to create the pattern. Let's first check to see if it's aligned by finding the slope. I'm noticing that this is going up 2 each time, and on the left the x's are going up 1. So if I think about my slope, it's change in y over change in x, so I get a slope of 2. If I have my traditional equation of a line, y equals mx plus b, I have 2x plus b. Let's plug in a particular point, let's say 1, 3, and y is 3, x is 1. I then have 3 is equal to 2 plus b, or b is equal to 1. I now have my equation, y is equal to 2x plus 1. Let's see if that makes sense. If you were to put in 1, do you in fact get 3? Yes. If you were to put in 2 for x, do you get 5? Yes. If we were to write this in function notation, we would write f of x equals 2x plus 1. The last part of our study on functions is to determine whether a relation is a function or not. If you remember that every input has to have one and only one output, we can take a look at our line. We've kind of been saying all along that lines are functions, but every single x has only one y. Here at x equals 1, we have a y value of 2. Here at x equals 2, we have only one y value of 3. All along here, every x value has only one y value. Conversely, that was example 1, if we were to take a look at the second graph, you've actually never seen anything like this, but let's pick an x value. Let's say x value is 2, and I put a point on this parabola, if you will, or this curve. I notice that I have a point here where it looks like it's 2 comma, maybe a little bit more than 2. Doesn't look like it's quite 3, but let's say it's like 2.7. However, at x equals 2 over here, I also have negative 2.7. So this x value actually has 2 different y values, so I know that it is not a function. Some people like to use what is called the vertical line test to determine if a function is not. And what you can do is you can draw a vertical line at every point. And if that vertical line only passes through one point, as is the case of this line, each time, see how it only intersects in one point? It is a function. If you intersect in more than one point, it is not a function. So if we take a look at this parabola on the left, if I were to draw a vertical line, each vertical line only intersects at one point. Same thing here. This is actually a trigonometric curve. This is a sine curve. You're going to learn about a curve like this in pre-calculus when you're a senior. But notice I'm only intersecting at one point. So yes, this is a function. I forgot to write over here. This is also a function. Okay. However, here, this curvy thing, if I were to draw a vertical line, definitely not a function, because not only does it go through 2 points, but it actually goes through 3 points. So this is not a function. Feel free, go back to this video as many times as you want, pause it, press play again. Hope you enjoyed. See you tomorrow.